All right, so from first you can see what your seniors are writing. Shouldn't it should become better to the form 5 first? You have 1 month plus before your actual practical. Kelly is mana you are the partner. Yeah, I see mostly 5 omega. Okay, I have some gamma already responding. And I do hope that you guys are sharing not only for physics, I think biology and chemistry as well, right? All right. Okay. So any other experience sharing? Form 5 who have just entered, please enter the class point so that you can actually respond all the way. Jason, you influence my sentence. YouTube all the way. Well, YouTube is one method. So you have to be alert on what I'm gonna be sharing today's lesson. Okay, while the seniors are still typing one thing, I hope you guys are still listening to my explanation in Google Meet. In order to prepare this particular seminar, all right, I went through at least 3 teachers' YouTube videos, summarize what they have taught, and one of them were actually examiner, paper 3 exam setter, and I try to compile everything that they mentioned into this particular seminar. I have to inform you guys that I am not part of the examination board, but how I teach is I go and watch a lot of their videos, right? Because I cannot attend physically, so I watch their YouTube videos that they have been sharing. So I compiled everything into this particular video, this particular seminar. Okay, so I hope it does help all of you instead of you guys going to listen to them. Since I've already compiled it, and you guys can actually listen to what I'm saying here. All right, so I am going to start sharing after seeing all this thing that you guys are showing. Okay, so those are the things that your seniors actually shared out. Okay, all right, let's go to the next slide. All right, so what we're going to be covering today is actually KSSM Physics Paper 3. The code is actually 4531/3. It's a new format for all of you, Form 4s and Form 5s. Priority to the Form 5 because you guys are the first batch. So this paper 3 is actually known as an integrated science practical test. There's 3 questions when you enter the exam hall. There's 3 questions, 1 question physics, chemistry, biology, but the sequence of the question is not, it could be shuffled. All right, question 1 could be physics, it could be biology, it could be chemistry, question 2 and question 3 as well. And then you only answer based on the subject you registered. So if let's just say you registered biophysics and chemistry, which means you have to answer all 3 questions. If you only registered biology and chemistry, you have dropped physics, then you only answered biology and chemistry question, or the other question also lah. Other subjects, it based on what you have registered in SPM. So each question is allocated 15 marks. This particular 15 marks is actually, let's just say for physics, the 15 marks is paper 1, you have 50 marks. Paper 2, you have 100 marks. And then paper 3, this particular practical paper is 15 marks. So total for physics will be 155 marks. Okay, so if let's just say you did not attend for your paper 3, you would get 0 out of 15. And then your total mark will be only from paper 1 and paper 2 out of 155. All right, so which means you need to attend the practical test as well. If you do not attend the practical test, you'll get 0 out of 15. That mark is still being considered. Oh, 165. Okay. Thank you. Okay. Thank you, Vidarshana. So anyhow, if you did not attend either one of the paper, it's going to be 0 out of 165. All right, same thing for biology and also chemistry. So it is not paper 3 alone, stand alone on itself. Okay, so this particular 15 marks is part of the total 165. Okay, the allocated time depending on the subjects that you registered for your SPM. So if you have 3 subjects that you register, okay, each paper actually is allocated 5 minutes preparation plus 40 minutes to carry out the experiment and also to answer the question paper. So if you have 3 subjects, you will have 15 minutes preparation and 2 hours to do your experiment and answer. So if you registered 2 subjects, that's going to be 10 minutes preparation, 80 minutes experiment. So far, I haven't seen students only taking 1 subject, which means they drop 2 subjects in science and they take 1 maths and 1 science subject. I so far haven't seen this situation before lah. Okay, so it's either 3 subjects or 2 subjects. So let's go next. Next should be video. Okay, let's see. Let me share a video. Can you hear the music?
Yes.
All right, good. Okay. So that was actually what happened the previous in November. All right, whereby the seniors actually did carry out the paper 3 as part of their trials. I thought I signaled you that time. Okay, so there are actually 2 types of question in paper 3, including for biology and also chemistry as well. So the first type of question is actually guided whereby the procedures are actually provided to you. The question is 1, 2, and 3, right? So question 1 and question 2 are normally guided questions. A sample of it is actually here. Wait, let's see. Okay, so this is a sample of a guided question. Okay, the list of apparatus is given. Okay, so within the 5 minutes, you are supposed to check. And I heard from one of the videos that was actually being given, the talk was actually given by the examiner, the person who actually set the exam paper lah. He actually said that all the apparatus for chemistry, biology, and physics might be all placed inside one pail or one basin. For the Form 5, you actually did had separated chemistry, one beaker, one particular buckle, and then physics one buckle, and then chemistry one buckle. But I heard that particular examiner said they might put everything all into one particular buckle only. So which means that you need to identify the apparatus itself and also to separate them out into chemistry, biology, and also physics based on the list. Okay, so please do take note. We have no idea what's going on yet because the upcoming paper 3 that's going to happen in 15th of February, so far I don't think so any of the teachers will know what is going to happen. Okay, so do be prepared lah. Okay, so this is a sample of the guided question. They tell you what is the aim. They give you the diagram. All right, they give you all the steps, right, that you need to do in order to carry out the experiment. It's like your textbook experiment questions. All right, then you have to answer the questions, you have to do the experiment, do the table, the graph, and then answer some gradient and then some higher order thinking questions. Okay, so this is actually guided. Okay, let's see. For unguided means that there is no procedure given, and it's a question for paper. It's a question number 3. So for the Form 5, your trial, it was your biology that had no procedure at all. All right. It could be physics, it could be chemistry. So please do take note about that. Okay. So a sample of it for the Form 4 to have a look. A sample of unguided. All right. Again, apparatus confirm given to you. So you have, like, for example, there's a hacksaw blade, there's a G-clamp, stopwatch, plasticine, and electronic balance. You would later on know that the minute you see hacksaw blade, plasticine, and electronic balance is definitely the inertia experiment. Okay. Then when you look into the question, they give you a situation. All right, a situation whereby this is the problem statement, and then they give you a diagram. So you can see that on the tree shot, this is only one person. The driver is actually cycling very happily, but then when there's 2 person on it, his facial expression changed already. So you have to plan out your experiment, and based on the apparatus and the materials provided in the list of apparatus, and then you have to state the method to handle the variables, which means you have to write the procedure, and then you have to write one precaution step. This is a 4 marks. So 3 marks is actually for your procedure and 1 mark is actually for your precaution. All right, and then you have to carry out the experiment, give the data by itself, and then you have to plot your graph, and then based on the graph determine what is the relationship between the manipulated variable and the responding variable based on what you have. So this is question number 3 is very open-ended. Okay, it can be the same as the one that in the exam or in your textbook, or it can be slightly different. All right, why slightly different? Later on, this session will cover this particular unguided question as well. Okay, so that is the 2 types. So how is the marks being allocated? Right, distribution of marks, all other items that you have learned in writing the compulsory experiment. Okay, I'm aware that you guys have been in MCO for 2 years, so you might not have carried out a lot of compulsory experiments. Even if you had carried out experiment, the teachers might not ask you guys to write a report so much. But the things that by right you should cover up is the aims, the inference, hypothesis, the precaution, the observation, operational definition. All right, so question 1 and question 2 are guided practical. So the marks is distributed this way, whereby the variables, all right, the variables is 2 marks, tabulation 6 marks, the graph is 3 marks, gradient 3 marks, and a higher order thinking question 1 mark. That will total up 15 marks. So you would notice one thing, they did not allocate marks for you guys to actually carry out the experiment. It is actually the 15 marks is actually based on what you write inside the how to say, the question itself. Okay, so but one thing, if you do not know how to carry out the experiment, which means your tabulation marks would be missing, your graph could be missing marks, you don't have marks for gradient and higher order thinking question, depending whether you tembak betul or not lah. All right, so you still need to know how to carry out the experiment properly in order for you to get the 15 marks here. The 15 marks is based on what the examiner is going to mark on your paper. Okay, so then question 3, the non-guided practical. All right, the allocation of marks is slightly different. It's procedure and precaution 4 marks, 3 marks for procedure, 1 mark for precaution. Tabulation 6 marks as usual, graph 3 marks, same. Data analysis 1 mark, typo here, and higher order thinking question 1 mark. All right, so the total marks would be 15. Okay. So if class, if you have any questions that you want to ask me while we are carrying this out, please, you can just type the message as usual at the chat room there. Okay. But please try not to send me the message at WhatsApp or Telegram because it's very difficult for me to look both ways. Teacher, are the experiment questions usually recycled from previous SPM papers? I'll get to that question in a short while, Daryl, because it is something regarding the compulsory experiment that I want to explain here. So the compulsory experiment for every single subject, they have a certain amount of compulsory experiment. I am aware that chemistry have 30 over compulsory experiments. From 5, you need to double confirm with that. For physics, we have 19 compulsory experiments that I have noticed and I have already listed out. Okay, so 11 compulsory experiments for Form 4 and 8 compulsory experiments that needs to be conducted throughout the Form 4 and Form 5. So Form 5 would be thinking you have a lot of experiments you guys haven't carried out. So this is what's going to happen for the next few weeks. The teachers, we have already decided that we will carry out experiment for 2 weeks when you guys enter the lab for biology and chemistry, physics as well. So Form 4 also, you will carry out experiments also, but you will focus more on the Form 4 experiments. So the compulsory experiments are this. All right, these are the 11 compulsory experiments that is in Form 4 syllabus. So I'm going to explain one by one. So Daryl, to answer your particular question, the experiment question is definitely coming out from this 19. All right, the experiment question is definitely coming out from this 19. And because you only have 40 minutes to carry out the experiment and to answer the question, they cannot give you a time-consuming experiment to do. So which means out, like, for example, this particular list, I can eliminate probably about 3-4 experiments already. Okay, because you need to make sure that you carry out the experiment and finish it in time. All right, so like for example, the first experiment to carry out investigate scientific investigation and write a complete report on simple pendulum experiment. This experiment can be carried out in 15 minutes. So which means this experiment could possibly come out in the practical test. Okay, then this is to determine the value of gravitational acceleration. Textbook page 48. All right, Form 4 textbook page 48. But this one, I doubt they will come out because they need to use a photo gate. Photo gate is a very expensive apparatus, and it's not possible for each school to actually buy minimum 60 photo gates. All right, so I don't think so this question might come out. Okay, this is me analyzing. Okay, so experiment to determine the relationship between inertia and mass. This one that could come out because they just need a saw blade, plasticine, stopwatch, which is already existing inside the school. So experiment number 3 could come out. Okay, and then specific heat capacity of water and aluminium. For me, this one take too long of a time because you need to measure the temperature from 20 degrees Celsius, 30, 40, 50, 60, 70, 80, 100 degrees Celsius. So that is very time consuming. So because time consuming, I doubt this experiment will come up. Same thing for specific latent heat. Okay, I also think that it's going to take a long time. All right, so number 2, number 3, number 4, and number 5 already cancelled out already. Experiment to determine pressure and volume of fixed gas. All right, this one very fast can carry out. So this one possible. Okay, but when you want to determine to change the temperature, right? This one maybe, but this one could be the secondary backup choice already. All right. If comparing pressure and volume, you do not need heat temperature. All right. So it is faster to carry out this experiment. When you require heat, you will need how to say you it will take some time. All right. Unlike chemistry, a while you can get the result already. They want the experiment to be carried out fast so that you can actually finish the experiment. They won't give you an experiment that's too long, or too how to say that requires a lot of your time. All right, don't form five, don't condemn my paper for trials. Okay. All right. So number 9, experiment to determine the refractive index. This one also possible. All right, because you just need the light, okay, and also you need a prism. So to determine the refractive index also possible. And then this one to determine the relationship of object distance, U image distance. This one for me is also maybe, because this particular experiment needs to be carried out in a dark room. All right, so if carrying out in a dark room, whereby some students doing physics need the environment to be dark, but some other students are doing chemistry and biology, which might need the room to be brighter, it might actually cause some problems. So for Form 4 syllabus, the one that I think possible come out is 1, 3, 6, 9, 10. Possible. All right, because of the time in order to do the experiment. Okay. So this is actually for the Form 4. Okay. I hope you have screenshot or whatever it is, because I'm going to go to the next slide already. Okay. Next is actually the Form 5 syllabus. Form 4, even though you haven't Form 5, but you're going to be in Form 5 in March already. So just take note on this. Okay, so for the Form 5 syllabus, experiment to investigate the relationship between force and the extension of spring. This is a confirm very easy to carry out, because all they need is a spring, a meter ruler, and a water bottle. All right, so this one can be carried out. Experiment to investigate the effect of pressure in liquid. This is a possible maybe. All right, this could also come out. All right, and then determine a gas pressure using a manometer. This one also I think it's possible, but not many school have so many manometer. Okay, not many school have so many manometer. Okay, then next is actually compare and contrast ohmic and non-ohmic conductors. This one definitely could be possible. Okay, describe the factors that affect the resistance of a wire. From 5, you did this particular experiment the other time during your trials. All right, it was actually this particular experiment that came out. Describe factors that affect resistance. So you had a length affecting resistance experiment that day. And then conduct an experiment to determine EMF and internal resistance. This one also could possibly come out. Okay, then describe the effect of current carrying conductor in magnetic field. I've checked through the textbook. This one is a so-so for me. Okay, whether it will come out or not, because don't know. I had a sense that it might not come out lah. Okay, and then explain factors that affect the magnitude of force on the current carrying conductor. This one also I don't think so will come out. Okay, so if it's a Form 5, the things that I think might possible come out is 12, 15, 16, 17. So that would have already cut down to 10 experiments for physics. Okay, again, this is only my interpretation on based on the apparatus and based on the time taken to carry out the experiment, because anyhow the experiment need to carry out in 10 to 15 minutes, and for the remaining time to be writing out the answers. Okay, so Daryl, does that answer your question? Before I proceed, do you have any questions for me? The rest of you, are you still there? Okay, kalau tak ada, I'm gonna proceed. All right, so let's start. All right, let's go to I hope that you guys have prepared the question that I gave you guys the other day. This particular paper 3. Okay, so open it up because I want to see some of your answers. I want to see some of the how you guys write. Okay, I hope all of you are ready. I only have 85. Okay, all the best whoever who did not attend. Okay, so from this particular first part of the question, all right, this is a guided experiment. Now we're going to cover guided and unguided experiments. All right, so for the guided experiments, okay, the first part of the question says that you are asked to investigate the relationship between the period of oscillation T and the length of the pendulum L. Okay, so from this particular part of the question, can I know what information can you all get from this particular question? All right, please identify and let us know what information can you get from this question. All right. So I see many people writing manipulator variable, responding variable, ways to set up apparatus. Then you have the aims, fixed variables, length of the pendulum. All right, good. So you need to understand that whatever that is given to you is it is a keyword and important stuff for you guys to actually know what you're writing, what you're going to do throughout the whole entire experiment. So very good that I can see that most of you can answer that already. All right, so I'm going to close this particular submission now. Okay, so what you guys actually wrote, okay, there. Wait, Okay, what you guys actually wrote here is correct. That it is actually manipulated variables. There are responding variables as well. So the main important thing is actually this particular first sentence. In this experiment, you are required to investigate the relationship between the period of oscillation and the length of the pendulum. So this is actually what we know as aim. And when you write an aim, we are actually writing the relationship between the manipulated variable and the responding variable. So the manipulated variable is either the period of the oscillation or the length of the pendulum. And do take note, one particular thing is that they already put a symbol there for you guys. There's a real reason why they actually put the symbol there already. It is actually whereby after this, you can actually you can actually directly use the symbol already. You don't have to spell out what does L represents or what does capital T represents. So correct that most of you said that it is actually to identify the aim, the manipulated variable, and the responding variable, and this is how you're supposed to set up the experiment. All right, so this is a guided experiment, so the apparatus is already set up. They are testing students whether they know how to set up the apparatus or not. Okay, and please do take note. This is going to be one of the experiments that I'm going to prepare for physics. So please do take note of this particular thing. All right, this particular part, how you actually going to clamp the experiment. Okay, so let's go next. All right, so after this, okay, let's talk about this particular apparatus part, okay, this whole entire thing, and then the table. Because I took this particular question out from a workbook, so the table is actually given, but in the real actual exam, the table will not be given to you. All right, in the real actual exam, again, table is not given to you. So, lucky thing that they gave lah. Okay, so in this particular case, you see, set the length of the pendulum to 60 centimeter. Mass of the pendulum is 250 gram. Displace the pendulum to the left and let it go as shown in diagram 1.2. Actually, you will notice this particular word. Now, when you're dealing with a pendulum experiment, you need to identify the word that they use. They said let go. Let go means just to release. Many students, when they deal with a pendulum experiment, they always push the pendulum bob. When you push the pendulum bob, you are actually allowing it to have initial velocity. Letting it go means that the initial velocity by right is 0 meter per second. All right, so please be alert when you carry out the experiment for pendulum. You're supposed to let it go, finish. You just release the pendulum, not push the pendulum. All right. Then record the time taken for the pendulum to make 10 complete oscillation for the first time as T1. They repeated the step to obtain the time taken to make 10 complete oscillation for second time, because this question is taken out from the book. All right. Record the reading of length L and time T1, T2. So they said this is being set at L60. Then complete the table and calculate the average time. Then repeat the procedure with L equals to 20, 30, 40, and 50 centimeter. So we know now that the length of the pendulum is the manipulated variable because it is being manipulated, is being repeated. And then you have to record using the stopwatch for the time taken. So then the period of one complete oscillation is the responding variable. The length is the manipulated variable. Okay, so this is how we identify the manipulated variable and the responding variable out. And in this particular procedure as well, they actually give you a hint what is the constant variable. All right, so can you all guess what is the constant variable? All right, can you please give me the answer? What is the constant variable for this particular experiment? What is the constant variable? And please note, constant variable is not one answer only. It could be many. Okay, I keep seeing mass of pendulum. Number of oscillation. Height of the pendulum being released. Okay. All right. So I'm going to stop the submission. I see many have repeated the answers already. So most of you gave us mass of the pendulum, weight of the pendulum, height of the pendulum being released. This is a very interesting answer. Number of oscillation, complete oscillation. Okay, so pendulum. All right. Initial velocity. Okay. All right. So I'm going to save this first, and I'll get back to this particular answer in the next few slides. All right. So based on the experiment, right, what is the manipulated variable and what is the responding variable? So while I want you guys to give me the answer, please write MV your answer, RV your answer, both in the same selection. Then I will tell you guys what is the correct method to write the manipulated variable and the responding variable. Vidarshana, try to close the class point and then open back again, Vidarshana. The rest of you, I want you guys to give me the answers based on what you normally will do. Alright, remember there's no right and wrong answer. Okay, I see most of you are actually writing this almost similar answer. Okay. So let's have a look for a while. Okay. So let's have a look at this particular part for a while. Okay, when you actually write manipulated variable and responding variable, actually the tips is actually to refer back to the aim. Okay, so the aim is actually period of oscillation and length of the pendulum. Okay, so in this particular case, the answer for manipulated variable is length of the pendulum and the responding variable is period of oscillation. But let's have a look at the answers that was given. Length of the pendulum, okay. Time taken to make 10 complete oscillation. Um, for me, actually, this one can be accepted. All right. But it would be better if you can write what is given at the aim. All right. Then you don't have to headache all the time. Just follow back the aim. So the aim is actually period of oscillation. Okay. So it can be acceptable as well. All right. But as I said, the best answer for a responding variable is based according to the aim, and the aim is actually written as period of oscillation. Another student actually wrote length of the pendulum, okay, and period of one oscillation. Okay, can be acceptable lah. All right, because one oscillation is also there. But there is one particular thing. If let's just say, okay, if this particular question comes out in unguided, you can actually write MV. Remember just now I told you guys about the symbol? Length, they use the symbol of capital L. Responding variable, you can actually use, just now was actually capital T. This one also get marked. But then one thing lah, try not to do this lah, okay? This is just in case you memang dah blank out already. Like, I think some of the seniors quite blank out the other time during their trials. All right, you can, if write length, can still accept, but do not just write pendulum, which means the student wrote MV, manipulated variable, as pendulum, responding variable as the pendulum only. I think I saw this particular answer just now. Someone just wrote the word pendulum. All right, pendulum is an apparatus. You cannot use apparatus as a variable. All right, a variable, you need to have a physical quantity, which means that it needs to have measurable. It can be measured. All right, you cannot use the apparatus or the materials as your variable. Okay, so then I also ask, state the constant variable. All right, so the constant variable, all of you have already given me the answer just now. Okay, the previous part, you guys have gave me the constant variable answers. So over here, as I noticed that a lot says mass of the pendulum, height of the pendulum being released, actually it's not wrong, it's correct also. So if, like for example, this Zeyong, if you have a written constant variable height of the pendulum being released, which means every single time you release the pendulum, you need to measure the height. All right. But in order to constant it, actually the best way to fix that particular height problem is actually to ensure that the angle of the pendulum being released is constant. Then the height will always be constant. It's easier to measure that way. All right. And then I saw Bunhan's answer. Where's Bunhan's answer? Initial velocity. This is probably because I already mentioned just now that if you were to release it and you were to push it, it will actually cause the reading to change as well. All right, so you have to fix this initial velocity as well. So by fixing, how to fix it is to make sure that you always release and not push the pendulum bob. All right, so and then this one, Edmund actually wrote pendulum only. All right, again, as mentioned, do not just write the apparatus. All right, so tips in case they ask for constant variable. If they ask for constant variable, you need to refer to the theory of the experiment. This is a pendulum question. All right, if there is a theory, then they will need. All right, but if you look at the questions that's in the paper, that's the formula there. Okay, a physical variable, all right, whether it's manipulated, responding, or constant variable, it needs to be a physical quantity that needs to be constant. It needs to be fixed. If you don't fix it, it will affect the reading of the manipulated variable and the responding variable. So, like for example, the height. If the height the starting point of the pendulum is different. All right, some you're going to pull up very high up, some you just pull up at this particular position. So it actually affects the period of the oscillation as well. So I can accept height of the pendulum being released, and I can also accept the initial velocity, because if you were to push, sometimes you push too much, or sometimes you just push a little bit, or sometimes you just release it, so the initial velocity changes. So you need to fix this particular initial velocity so that it doesn't affect the time, the period of the oscillation. So these two I can accept. But as mentioned, variables must be a measurable physical quantity. The word physical quantity is always being repeated because physical quantity are quantities that can be measured. So whatever variable that you mention needs to be able to measure. It cannot be apparatus. It cannot be the size of the material, a bigger pendulum or a smaller pendulum. You want to say it's the mass of the pendulum, the diameter of the pendulum, density of the pendulum. Density, I don't think so. It would differ that much lah. All right. So you need to be specific. What variable are you talking about? So whatever variable that you learn in Form 1, Form 2, Form 3 cannot be used in physics. Because in Form 1, Form 2, and Form 3, I notice sometimes they said measuring the meter ruler. The constant variable is meter ruler. Even if you use a measuring tape, you still get the same answer. All right. It has nothing to do with the variables. So in physics, it has to be a physical quantity that can be measured. So please take note of this. All right. So, okay. Um, I'm going to give you guys a 5 minutes break. Okay. Please ignore the number down here. This number does not represent the number of pages. All right. So I'm going to give you guys a 5 minutes break, and we will be back here in 3 o'clock. If that's okay, go for a quick break or a quick toilet break or whatever. So we'll get back here in 5 minutes time. Okay. Right, while waiting for the rest to come back, I promise to start at 3 o'clock. Does the rest have any questions for me so far? Uh, I kind of know that I'm going a little bit slow on this, but honestly, to say from the recent trial paper, some students can't even answer what is manipulated variable and responding variable. No answers, for those who's in front of the computer or the phone right now. Not really. From five, I hope that you guys are your momentum towards your SPM is already on and moving faster. Because try not to get too much into the holiday mood. Your school reopen next week, then after that, some holiday. 2 weeks later, Chinese New Year. Chinese New Year comeback is already oral hearing test, your ujian lisan, and then you will have your paper 3. Okay, then after not long after that, it's going to be your actual SPM already. So please get ready from fives. Form 4, don't think it's a honeymoon year. You better get yourself prepared and settle your Form 4 syllabus first. Okay, it's 3 o'clock already, so I'm gonna get to here. Now, um, after getting the variables right, the next thing that you need to do is actually to tabulate the data. But in paper 3, when you want to tabulate the data, it is very important for you to carry out the experiment and also to know how to read the apparatus, read the readings. Okay, so in this particular case, how many decimal places that your answer is going to be inside the table. All right, it depends back on your apparatus. So let's just say, for example, this particular experiment has analog stopwatch. So if you have an analog stopwatch, you need to know what is the smallest reading on your stopwatch. If you're lucky enough to have a digital stopwatch, you just have to copy whatever that's there. And that also depends back on how many decimal places are you going to write, because digital stopwatch is normally minute, second, sorry, hour, minute, second, and then there's another double digit at the back there. Okay, so that is actually smaller than second. So it depends on how the sensitivity of your apparatus in order for you to write down inside your apparatus in your table. Okay, and for your information, when we have a actual exam, all right, your actual paper 3, um there will be a school teacher who has to carry out the same experiment as you, isolated in another case. So for the Form 5, the other time when you guys are doing your trial, right, actually by right, me and another teacher of biology and chemistry, we was actually carrying out the experiments separately in another lab that is on the same day as you guys. So when they cross check the data, it is actually based on our data as well. Okay, based on our result as well. Okay, so you can identify that actually we carry out the experiment quite fast because you saw all the science teachers walking all over the physics the 3 labs the other day. All right, so the experiment carried out has to be easy to be carried out and fast to be carried out. Okay, again, the main reason you couldn't get your physics result was because you guys don't know how to set up the electrical experiments. Okay, which I'm gonna drill you guys more later when the school starts. All right, let's talk about the sensitivity of apparatus. We have a stopwatch over here, so it's very important for you guys to know how to actually. Let me hide this particular thing first. Okay, now I understand why I cannot hide. Okay, in this particular case, you need to know how to take the reading. So how are we going to take the reading? Okay, so in this case, the smallest reading, the sensitivity is based on this particular part of the stopwatch. So this is 5, so this is 4, 3, 2, 1. So this is 1, and then you have to identify how many small lines over there. All right, so 1 second, if there is 5 small lines, then the smallest value is going to be 0.2 second. So which means your table, your whole entire table, when you do the reading, is all 0.2, 1 decimal places, and the answer has to be even. But if let's just say there are 10 segments in there, so it will be 1 second divided by 10, the smallest reading is 0.1 second. So 1 decimal places, your answer can be odd or even answer. Okay, now I know during the trials, there was one situation whereby the reading got stuck. Let's just say this is 5 and this is 6, and then it got stuck in the middle here. Okay, may I know, in this particular case, let's just say this is 5, 0.5 second and 0.6 second. Right? Can you all write your answer? What would you write this answer? What would you record this answer as inside the Google Meet chat box, please? If the arrow starts between 0.5 seconds and 0.6 seconds, how would you write your answer? Because I'm sure many of you, especially the Form 5, you all experience this. What answer would you put? Will you write 0.5 or will you write 0.6 or will you write 0.55? Okay, good. I can tell you there are from two different sources, both experience, both how to say, both acceptable. One answer actually mentioned, all right, one teacher actually mentioned you can give the answer as 0.5 second, you can give the answer as 0.6 second, or you can give the answer as 0.55 second. All these three accepted. Okay? If the answer stuck in the middle, you can choose 0.5, you can put 0.55, you can also put 0.6. For me, I will go for 0. If it's stuck in the middle, okay? The examiner actually said, the one who set the exam paper said that go for the smaller value. Teachers who were experienced in marking the paper says that they accept 0.5, 0.6, and 0.55. But honestly, to tell you, in this actual practical exam, the teacher will accept all three. Okay? Main reason is because that they don't have the same apparatus as you all. Even if you get the same, you are in the same lab, your stopwatch and the person's stopwatch in the next table could be a different version as well. That person could have 10 small segments, you could only have 5 small segments. So for an examiner, we will accept 0.5, 0.6, and 0.55. But if you were to accept 0.55, make sure your decimal places in your table is all 2 decimal places, which means the rest of the answer is 0.60 or 0.50. Later on, I'll explain about this. So I hope you guys are clear with this. Okay, so these are supposed to be the data. Let's go back to the PowerPoint slide. All right, this particular table, I did my table already. Mana, my answer. Okay, so for this particular case, okay, please do snap a photo of your answer. Because I already asked you guys to do the question already. Please snap a photo of your table. I only want the table. I want to see your answer, please. Hey, please don't tell me you're sekarang kelang kabut want to go and take your reading. Why still no response one? Interesting. Finally. Bunhan, where's your line? Anyhow, thank you, Bunhan, for uploading the first picture. You want me to finish fast, you better send in as fast as possible. Alright. Answers are coming in. Thank you, Vidarshana. Ayoyo, semua tak buat ke MIA? Or AFK? Ni tambah masa lagi. I can only help to identify and correct your mistake if you guys will be able to put in your results. Halo, abang kakak semua, mana you punya jawapan tak buat ke? You're just starting to do, is it? Can someone respond? Do you need extra time for this? Loading. What is loading, Vinica? Cast point is loading? Or your photo is loading? Photo loading. Okay.
Teacher, I have a question.
Yes, Bunhan, go ahead.
For paper 3, do we need to write average for the table?
It's actually up to you. Average, which means you have to do the experiment 2 times. If let's just say you have if you think your first time reading is not going to be accurate enough, you can do 2 times to get the average. That would actually be much better. Or else 1 time will be sufficient. Bunhan, do I answer your question?
Yes, thank you, teacher. Because I
Alright.
messed up at the average part. Really bad.
Okay. I only have Bunhan as a representative for Form 5. You guys must be pressing the calculator right now. Teacher is too accurate. Miko, what to do? Advantage and disadvantage of being a physics teacher. Okay, I need to put extra time some more. Yufeng, ambil gambar betul sikit lah, Yufeng. Excuse me. Yuanming, so far there's no news of Form 4 having an exam. So far I know it's the Form 3. So far there's no news of Form 4 having an exam. They are only giving the Form 3 exam because Form 3 need to undergo streaming for Form 4. Because the problem of once school reopens, right, 2 weeks later, 3 weeks later is Chinese New Year. After Chinese New Year come back, students have to go on alternate holiday. Might need to go for alternate holidays because the Form 5 is going to start having their SPM exams preparation and all already. But Form 4, there's no alternate coming to school already. Form 4 is going to be fully 100% attendance physical classes already. Form 4. And please note that for my classes, please everyone masuk physics lab. Don't make me go until block F to call you all into the front. Okay, I'm gonna stop here already. Final result. Please understand that your PSS is actually assessment. We cannot consider Form 4 to have examination. is actually assessment. The only examination there is now is actually the SPM examination. All right, so probably gonna consider as your the form 4 one lah. We have no idea. I honestly haven't heard anything regarding the finals yet. Okay, let's see. All right. So okay, Wunhan, allow me to actually use your answer as the sample, okay?
No problem.
Okay, so in this particular case, obviously one thing is that there's no decimal places. Okay, table actually has how many marks? Table have 6 marks, you know. Okay, where does the 6 marks come from? Number one is obviously the labeling lah. Okay, the symbol has to be labeled. The unit tak ada, so that one is already -1 mark, -1 mark for the unit already. By right, it's supposed to be got decimal places. Here tak ada decimal places. So there also gone. Okay. This particular reading here got one decimal place, sini tak ada decimal place. So gone case again. So
Teacher,
probably, yeah.
I thought the stopwatch smallest reading is 1 second.
Uh for this particular question, stopwatch reading smallest 1 second? No. For this particular question that is even smaller than that, it's either 0.2 or 0.1. So there should at least have one decimal places there. Soto Bunhan?
Yes.
So you only get 1 out of 6.
Aye.
Okay, so let's go to this particular question. All right, so for this particular student, okay, so all this has 2 decimal places. Okay, I'm not gonna penalize, but by right it's only 1 decimal places, but all of it is consistent. So okay, and please note one thing. Examiners are supposed to check your answer one, you know. So they are being asked to press the calculator. And another thing is that you can actually program your calculator in order to calculate. How to program your calculator? I'm sure all of you did this. Example, 9 plus 9 divided by 2. So all of you had a problem just now. You took such a long time because you go and press 9 plus 9 and then press equal and then only you divide it by 2. Actually, you can do one thing in your calculator. If most of you would have noticed, the red color button on the left hand side top corner is actually alpha. Okay, alpha means alphabet, and it's pink color for a reason. Check at the black color second bottom row. You have pink color A B C D E F X Y M. Okay, so actually you can program your calculator by pressing alpha to have bracket A plus B divided by 2. And then when you press the calculate button, they will ask you a question mark. Then you key in 9 equals, then you see B question mark. Then you key in the second value. And then when you press the equal sign, it auto calculate the average for you. Okay, so that is actually how you program your calculator. This is a semi-programmable calculator that most of you are having. Okay, so please learn how to do that, because I know many of you did a very long time because you go and press 9 plus 9 equals divide by 2 equal sign again. All right, so for further information, I'll show this one physically in class. Okay, all right. So I'm not going to check all the value, but examiners are supposed to check the values lah, okay? So I'm checking only the decimal places right now. The decimal places here got 3. All right, so correct, and here got 2. Now, this is actually what you get from the stopwatch. All right, this is a direct responding variable. This is a calculated, this is a secondary data. All right, average time, period, and t-squared. These are known as average data. Average data decimal places is actually the same as the recorded or plus 1. So if the recorded one is 1 decimal place, your secondary data can be 1 or 2 decimal place. Maximum 4. But honestly, to tell you, no need to go until 4 because it's not possible to plot 4 decimal places on the graph paper. Okay, so please note the secondary data either the same decimal places or plus 1 only. Okay, so this one, okay, with this table, probably get 6 out of 6. This table also, I see all the values are 2 decimal places, all consistent, so good. This one, same thing as Bunhan. I have no idea why, almost the same reading also. No decimal places over here. All right. But the decimal places are quite consistent, so probably get three marks, around 3 or 4 marks over there. Okay, so here all decimal places consistent again because the table is already given. Okay, so for here, all decimal places is also consistent, so good. All right. So this is actually the tips that I can give you guys for a table. You don't need to spell out the physical quantity. All right. For example, length. All right. You do not need to spell Length. You can just directly write the symbol L because it has already been mentioned out at the first sentence of the aim. All right. Just use the symbol. All right. The decimal places must be consistent, and the decimal places actually depends on the sensitivity. Excuse me. All right, the decimal places depends on the sensitivity. If the apparatus only have 1 decimal places, don't go and put 5. Don't go and put 3. All right, or don't round it off to no decimal places. All right, so follow the decimal places, must follow the apparatus. How do we know? It's because the examiner will look at the control answer. The control answer is going to be one of the school teacher's answer. Okay, because the school, as I mentioned just now, the school teacher have to carry out the experiment the same timing as the candidates. Okay, all right, next is actually plotting t square against L. So I can very sure know that you guys didn't do. So I'm gonna give you guys uh 5 minutes like that to actually plot your reading. Is it possible? So I'm gonna give you guys 5 minutes to plot your graph right now. 10 minutes, okay. Nicole requests for 10 minutes, so I'm gonna give you guys 10 minutes to plot the graph, and with that particular 10 minutes, please upload the image. Yes, Yuan Ming, try to draw on the graph paper. Thank you, Vidarshana. You have 4.5 minutes left. Alright, I hope you guys can send in whatever you have right now. All right. Uh, since I only have 3, so I'm going to be showing this 3. Again, Bunhan's one first. Kailash and also Vidarshana. Okay. Let me rotate this particular picture first. Okay. All right. So I only have 3. So I'm just going to explain using this 3 while the rest of you guys actually check on your own graph paper. Okay. So when we are talking about graph paper actually has even though in your question there's only 3 marks there because they allocated the marks to other place, but in the actual exam graph paper also have 6 marks. Okay, so where is the 6 marks being allocated? Now, first thing first is actually the title is written. Please make sure that you write your title. So that's t square against L. T, because t square comes first, so t square is obviously on the y-axis, while L is actually on the x-axis. So here is written, there's one particular problem, Vidarshana. Is this T2 or T square? There's a difference. Okay, T2 is actually the second reading. T square is actually what the question wants. All right, so please make sure that you write properly over here. And then here is written L. Okay, so by writing the symbol for the axis, you'll get actually 1 mark over there. And then the other 1 mark is actually the unit. So you are actually supposed to write second square and cm. So the second mark is actually for unit for both. So you need to write both unit to be correct, then only you can get a second mark. Okay? Then after that is your axis, all right? Your scales needs to be starting from 0, all right? So you both started from 0, and here is 10, 20, 30, 40, 50, 60. Okay, this is good. Over here, this is actually 0.25. All right. Um, later on, I will actually mention this out. Okay, wait. I think it is better for me to tell you guys what is better for the marks. Then only we can come back to this particular work that you guys actually shown. Okay, so for the graph, the things that you need to have is make sure you write the symbol for the x-axis and the y-axis. The unit needs to be correct. All right, the scale needs to be correct. Correct scale means that both have to start from 0. Y-axis start from 0, x-axis also start from 0. So it's better for you guys to write double 0 over there instead of just a single 0. All right, always write double 0. And the scale has to be to the multiple of 1, 2, 5, or 10. All right, so which means it's going to be 1, the reading is 0, 1, 2, 3, 4, 5, or 0, 2, 4, 6, 8, 10, or 0, 5, 10, 15, 20, 25, so on and so forth, or 0, 10, 20, 30, 40, 50. All right, that particular multiples. Okay, so uh okay, sorry, I got distracted a little bit. Okay, so how do you identify the scale? All right, I'm sure most of you have problem identifying the scale, so I'm going to tell you guys how to identify it in a short while. It's actually to identify the maximum and the minimum first, and then plot each point correctly with a cross. All right, use a small x to identify the point, because there are some times that student actually used what a dot. All right, sometimes students use a dot. Try not to use a dot. A cross is better. All right, and then how to draw the best line. And the size of the graph actually it's 8 centimeter and times 10 centimeter. All right, I keep watching a lot of videos, and all the teachers are saying that the best size of the graph is actually 8 cm times 10 cm. 8 cm for y-axis and 10 cm for x-axis, which is the horizontal line. Okay, so which means the graph is minimum size is 8 cm times 10 cm. That's the minimum size. Okay, so sample, title of the graph. Okay, usually a title I mentioned y-axis versus x-axis. So if it's t square against L, then t square is on the y-axis, t square is on top, and then x-axis will be the L. And make sure you write the corresponding unit, which is second square and also centimeter. You can get this from the table itself. Okay, label the axis with the correct unit. Make sure, because here itself already 2 marks there. Okay, next is actually plotting the graph. Okay, the vertical y-axis and the horizontal x-axis scale must be correct, as I mentioned. 1, 2, 5, 10. All right, do not use weird numbers like 3, 7, 9, 11, 13, because it's very difficult for you to plot that particular value. And the scale must produce a large graph so that it can be plotted easily, so that you can actually plot all those values that you have. That's the reason why I mentioned previously at the table there, try not to have 3 or 4 decimal places. It's not possible for you to plot 3 or 4 decimal places. Okay. And then the size of the graph need to be 8 centimeter, okay, times 10 centimeter minimum. Okay. So like for example, I tried to plot a minimum graph, this particular minimum graph. Okay. This particular minimum graph is half of the page. Okay, from 5, especially 5 omega, previously I said it has to be more than half of the page. But by most of the teachers' question, the tips, right, it's 8 cm times 10 cm. This is the minimum 8 times 10 cm. Okay, so this is actually allowed. All right. Don't query on why I mentioned that previously. Okay, previous one is KBSM syllabus already. This is actually the KSSM syllabus. So you are allowed to have a 8 centimeter times 10 centimeter graph. All right, make sure the origin to the last point, from the origin to the last point. All right, and then make sure the scale is uniform, which means make sure that it is 02468 and not 0256, which means over here this particular value is the difference by 2, but here suddenly difference by 3, and then here difference by 1. All right. For the trial SPM, I've seen answer like this. You took the value from the table and you directly go in and write 2 cm to that answer, 2 cm to the answer, 2 cm to the answer. So that is actually real. That is actually wrong. The scale needs to be uniform. All right. The difference need to be the same difference. Okay. So please take note of this. I'm speaking from 5 omega because I haven't get the feedback from actually Pon Shahada on 5 gamma and 5 alpha, but please make sure that you guys actually do this particular difference as well. All right, write the value of the origin. Make sure write 0, 0. Make sure write double 0. All right, use a small cross to plot. Make sure the plots are plotted correctly and according to the data of the table. Don't change the data. I repeat, don't change the data. As in, because the best line when you draw, you notice that it doesn't fit. You go and move your cross up onto the graph. Do not do that. The examiner will cross-check your data, your table to the graph. So do not move your data. Just let it be. Okay? All right. All right. This particular part, okay, this graph, some student will think, oh, I balance the top and the bottom. This is the best graph because in physics, most of the graph is actually a straight line graph. But mentioning that it's a straight line graph, it doesn't mean that it has to pass through the origin. It doesn't have to pass through the origin. All right. So in this particular case, over here you can see, okay, over here you can see that this point doesn't touches the point. This one doesn't touch. This one doesn't touch. The other all 5 point doesn't actually touches the line. So this is actually not the best line. Okay. The difference between the points above the line or the curve and below the line and the curve must be 0 or 1, which means that above the line here there is only 1 point. There is only 1 point above the line, but there are 4 points below the line. So this is 1, here is 4. So difference between 1 and 4 is actually 3. So this is not the best fit line. Okay? So it needs to be a difference by 0 and 1. Okay? Again, this one you can see all the points are below the line. So again, this is not the best fit. Right. So the best is like this. this is not the actual graph. I just take somewhere else. This point touches. How come? This one touches the line. This one does not, and this one does not. This one touches also. So this 2 point doesn't touch. Okay, these 2 points, if it doesn't touch, this is below the line. So there are 2 points that doesn't touch below the line. There's no point that doesn't touches above the line. So the difference is actually 2. So technically, this is not the best fit line as well. Okay, so you have to be very careful when you plot the graph lah. Okay, as I said, labeling y-axis, x-axis with the correct unit, you get 2 marks here. You give a good scale, y and x-axis both correct, you get 1 mark. 2 points plotted correctly, 5 points all plotted correctly, you get 1 mark. The best straight line, and it has to be smooth, 1 mark. And then the minimum size of the graph is actually 8 cm times 10 cm. That is 4 big boxes going upwards and 5 big boxes going to horizontally. So now let's go back to your graph question. The 3 students who gave the graph questions just now. Okay, so let's go back to this. Okay, so for this particular case, this particular scale 0.25 can be accepted, all right, because this is a very big scale, all right, so I'm going to accept the scale. All right, then the points. So have to cross-check whether the points plotted correctly. So assuming that points are plotted correctly, so 5 points plotted correctly, and then I'll look at the best fit. So this one touches the line, this one touches the line. This one does not. This is 1 above and 2 below. So the difference of 2 minus 1, that will be 1. So this particular straight line is a best fit line. Okay, so line correct. And then the size of the graph, this is obviously more than 8 times 10. So this particular student actually gets 6 out of 6 for the graph question. Okay, so let's check another question right now. Okay, here, I need to move my monitor a bit so that I can see my second screen. Okay, so this one, t square L. So symbol is there, but there's no unit. Okay, unit is missing. Both start from 0. You see, this is a difference by 20, but here is a difference by 10. Kailash? All right, so this scale automatically no mark for scale already, because you jump 10. Okay, Yuan Ming, so the difference should not be more than 1. Yes, the difference of the points not touching the line need to be 0 or 1. It cannot be more than 1. 1.5 pun tak boleh Okay, so this scale is 0.4, 0.8, 1.2. Okay, this scale can, but because x-axis Kailash actually went from 0 to 20, then 30, 40, 50, so the scale 1 mark gone. Okay, assuming that the points is actually correct, because I'm not checking the points right now. And then after that is the best straight line. Okay, so this line, you can see that it actually touches 3 points. 1, 2, 3, but it doesn't touches 2 points on top. So this is not the best line. Okay, and then size of the graph, obviously more than 8 times 10. Okay, so which means Kai, you only got 3 out of 6. Okay, let's go to Bunhan's paper. All right, here t square L is there, so symbol is there. But I know one thing is there's no unit. You're so hungry, the unit go and eat it away. Next is actually scale. This is upper value, Bunhan. 0.25.
Yes. 0.25 differences.
Okay. Alright, can be accepted, but tolong tulis kosong-kosong, Bunhan. Then this scale is 1020. Okay, scale-wise correct. Next is actually points, again, assuming the points is there. Okay, then after that is the best line. Now, over here, 1 point, 2 points is actually touching. 1 above, 2 below. So the difference is actually 2 minus 1. So best line. Alright, another tips if best line, apart from the difference, the other tips that you guys have to take note of. The perpendicular distance between the point that doesn't touches and the line. I repeat, the perpendicular distance between the point that doesn't touches and the line needs to be less than 0.5 cm. Okay? If let's just say the point that doesn't touches is here, up here, this is more than 0.5 cm. So this particular line will not be a best fit line. Okay? So please take note of that. The distance of the points that doesn't touch with that straight line, it cannot be more than 0.5 cm. Okay? Please take note of that. And then size of the graph, obviously, this is more than 8 times 10. So here, Bunhan got 5 out of 6. Okay? All right, so I hope with that you guys are okay. Let's jump. What is the next? Okay, for graph, any questions? For graph question, any question? I'm already halfway there already. More than halfway. So any questions so far? How to practice makes perfect, Daryl. Okay. Let's see. Let me agak show you guys lah, okay? Let me show you guys how do I draw my graph. So first thing first, okay, draw your axis. So this is the axis that we're gonna be using. Okay, I'm gonna use the minimum line, minimum size of the graph. Okay. So first thing first, I will always write my graph. So graph of t square against L. So I have a tendency to always write my symbol and my unit first. L in centimeter. 00. Then I will label this. So that's 1, 2, 3, 4, 5. My table for L is until 60. So I have to write here. So this would be 10, 20, 30, 40, 50, and 60. So the problem right now is actually t squared. So I need to know how many lines can I find. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. In the actual graph paper, you should be able to draw at least 10 or 11 big boxes. All right, but here I only can reach until 9. Okay, so from my data, my biggest value of t square is actually 2.50. My biggest t square for length of 60 centimeter. So 2.50, I divided it by 9. Okay, because I want to get as big as possible. Try to remember to put 00. Just put 00. Is it that difficult to put 00? All right, the value is 0.28. So 0.28, if I want to get the scale, it's going to be 1, 2, 5, 10. All right, let's just say I want to fix this particular value. Okay, so if I want to get that, which means I cannot be 0.1, I cannot be 0.2 because it's going to be not enough space for 2.5. So I can only go for 0.5. So this is the minimum. So 0.5, 1.0, 1.5, 2.0, 2.5, and then 3.0. Now remember that my smallest size of my graph is supposed to be 8 cm times 10 cm. My 2.5 is actually my biggest value. So this 2.5 from 0 is already 2, 4, 6, 8, 10. 10 centimeter up already. And then my 60 is my biggest value. So it's 2, 4, 6, 8, 10, 12. My graph is already 10 times 12 cm. It's bigger than the minimum required one. All right, so my scale of 0.5 is acceptable. Okay, then I plot 20. My first reading is 0.85. So 0.85 would be somewhere here. 30 is 1.1. So 1.1, that would be somewhere here. And then 40 is 1.6. 50 is 2.7. So 2.1. And then 60, I memang pakai tembak one right now. Okay? Because I want to show you my best line. Okay. So how do I get best line? I will try to adjust. Daryl, please observe how I'm doing, Daryl. I'll try to adjust this so that I can have balance top and above. Okay, I somehow have a feeling it's like this. Okay, you see, I touched 2 points over here. I touched point number 2 and point number 4. Point number 1 is above the line. Point number 3 and number 5 is below the line. So 2 minus 1, that would be a difference by 1. Okay, and then I have to make sure this particular distance is actually less than 0.5 centimeter. So by looking at this, I know this is definitely less than 0.5 centimeter already. Okay, if we want to be exact, I can actually measure it. So in this particular case, this is my best fit. And does it have to pass through origin? No, it doesn't have to. All right, so this is actually how you draw. You have to adjust your line. So do I have to adjust my cross so that it's on the line? No need. Okay, so please remember, do not adjust the point. Okay, adjust your ruler and the best fit line. Okay, so this is actually how I plot my graph lah. Okay, now let's proceed. I think a little bit more only, then we are almost done already. Okay, so this one is actually, do you guys need to have a break before we continue with the gradient? Hello, do you guys need to have a break before we continue with the gradient?
I'm fine.
The rest?
I am fine too.
Teacher, is it okay to not start from origin? Cause in C, it says start from origin. Must start, no, as in your scale, your graph must start from the origin. All right. Like for example, if doesn't start from origin, means that your line, you start from 10. This is y-axis. Here's 10, 20, 30. This is what it meant by doesn't start from origin. Okay? All right, since all of you are fine, I'm just going to proceed with it. Okay. I think the only one not fine is as long as my vision is clear lah, okay? All right. So right now the question asks the equation of relationship between the period of oscillation and the length L is given by this equation. Using the graph, calculate the gradient of the graph. So this is actually 1 mark. Actual case is supposed to be 3 marks. So I'm going to go back to this particular graph. In order for me to draw the gradient, on the graph, you need to find the point. So I'm going to find, let's just say this particular point. This looks, you have to find somewhere that's nice, okay? So I'm going to draw this dotted line here. Okay, and then I have to find another point. Oh, this is nice. This is exactly at the cross. So I'm just go dotted line all the way. Please make sure in the exam use a straight ruler. I don't want to shift too much things already. Okay. I repeat, in the exam, please use a ruler. Don't use freehand like what I'm doing right now. So, and then after showing, identify your point. So that is 57. Y-axis is 2.5. Then here is x-axis is actually 1, 2, 3, 4, 5, and 0. Okay, so that's 5, 0, 57, 2.5. First point is 5, 0. Second point, 57, 2.5. So find your gradient in maths. M equals to y2 minus y1 over x2 minus x1. So y2 is 2.5 minus 0. X2 is 57 minus 5. So based on this, 57 minus 5, that would be 2.5, 52. So this answer is actually 0.05. This is actually based on the data. The one that I draw was actually 0.04. Okay. So but one thing, make sure you get the unit. So how to get the unit? You have to look back on the graph. The graph is your axis is actually y-axis minus divided by x-axis. So take the y-axis unit second square divided by x-axis unit, which is cm. So that would be second square divided by cm. Or the unit can be second square cm negative 1. All right, so that is how you get it. Get the unit of the gradient. Please take note of the unit. In physics, unit is very important. Okay? Or else you lose your mark all the way at the unit. All right, so I'm going to go proceed. Draw a sufficiently large triangle. If you want the answer as close as possible with the examiner answer, your triangle need to be as big as possible. All right. Correct substitution y2 minus y1 over x2 minus x1. That's according to your maths. Okay. And then state the value within the acceptable range and make sure you write the correct unit. All right. And do not put your answer in fraction. I notice some students love to leave the answer in fraction because the calculator gave you the answer in fraction, especially those who's actually using 370 or 570EX. They leave the answer in fraction. Physics cannot leave the answer in fraction. All right. So from here, based on the equation given, your answer in 1D1, calculate G in SI units. So I'm going to do this particular calculation. So I hope you guys can have a look. I notice most of you might not be getting it correct. So the equation of the graph that is given in the question is T 2 pi cert of L over G. The gradient is actually, the graph is actually T square over L. So the gradient is actually T square divided by L. So you need to change this equation to T square over L. So I'm going to square both sides to become T square equals to 4 pi square. Square of cert, it cancels out, become G. So the gradient is T square over L. All I have to do is actually shift this L to the other side. So T square over L equals to 4 pi square over G. So this is actually the gradient. Mathematics, people. Okay. So 4 pi square over G, and my gradient just now was 0.05. Please take note that the gradient that I found just now was 0.05 second square cm negative 1. The question asked for SI unit, but I'm not changing anything yet. All right, because 4 pi square is constant value. So G is 4 pi square divided by 0.05. So I'm going to again press my calculator for this. and I got 789.57. So this one, the unit now becomes centimeter per second. You want it to be SI unit, you need to change the centimeter to meter. So to change centimeter to meter is actually to divide by 100. So that would be 7.896 meter per second square. Sorry, -2. Okay, so that is how you do the question. Um, if this question comes out in maths, you'll be able to answer. But unfortunately, when it comes out in physics, you guys cannot answer because you cannot link physics and maths. So remember, try to link it with mathematics also. Okay, so screenshot this. I'm not asking for the answers from you guys already because I know you guys are a bit exhausted as well. So am I. Okay, so I'm gonna go next. Question right now says compare your answer with the actual value of 9.81. This answer is 7.86. But my answer is the actual one is 9.81. So all you have to do is just state that answer, calculated answer is less than 9.81 meter per second square. If you get almost similar, then you just write almost similar. If it's bigger, then you just write bigger because it's experimental exam. So it based back to your own data. Don't look at your friend's answer because your friend's answer might be bigger, but your answer might be smaller. Okay. So state one precaution step. All right. To improve the accuracy, there's a few precaution steps, but try to memorize one particular method. Okay. So just a quick for me to get a rest for a while. Can you please state one precaution step? All right, while I go for a toilet break. I see a very interesting answer. Shenling and also Yu Feng. How to place the eye parallel to the scale? Parallel masuk apa? Shenling and Yu Feng, you need to show me how to place the eye parallel to the scale. Do the experiment in vacuum. Yuanming Yuanming. How am I going to find 80 sets of vacuum set for you guys to do the experiment? Turn off the fan in the room. Okay, I'm not going to give additional time. Use ruler and protector. How? How? Show me. Jiazhen, you're replying to which one? How do you read parallel? I'm not giving additional time. I'm just gonna accept whatever that is here already. Jiazhen, look at my video. Parallel means what? 0 degrees eh? How to parallel? Okay, let's see. Do the experiment in vacuum. Turn off the fan. Repeat the experiment a few times to get accurate reading. Eye level must be perpendicular to the reading. Use an average measurement from a set of measurements. Okay. So let's see. Rate the reading at eye level. Keep the eye parallel to the stopwatch by observing the results. When observing the results, height of the pendulum release must be same at all times. Repeat the experiment a few times. Take the average reading. Make sure the reading is eye leveled. Okay, out of this whole entire page, I think the most correct one would probably the closest one is actually Jensen. Okay, read because in experiments, right, they would want you to give how, why, and what apparatus are you talking about, because the list of apparatus is already given to you. So by stating all this, it's not specific enough. You need to mention what is the apparatus. So keep the eye perpendicular to the stopwatch when observing the results. This is how. You did not mention why. Okay, so why is actually to avoid parallax error. Okay, so height of the pendulum release must be same at all times. So this is how ma. What about the why? Okay, so that it will be constant throughout the whole entire experiment. Okay, repeat the experiment a few times and take the average reading. This is the most accurate one lah. Okay, make sure the reading is eye level. How is it considered eye level? All right, observer eye is parallel to the reading of the stopwatch to avoid parallax is spelled with P-A-R-A-L-L-A-X. There's no E. All right. So please be very careful, because if you spell wrongly, even this is perpendicular, you spell wrongly here, you're going to get 0 also. Okay, so please be aware of that. Eye level, must be perpendicular to the reading of the scale, reading of the stopwatch. We should space out when pendulum is oscillating so that we can avoid the pendulum from hitting our eye. Tarani, you're gonna be oscillating the pendulum way too high already if you're gonna hit your eyes. All right, avoid zero error. How to avoid zero error? All right, using an average measurement of from a set of measurements. Okay, repeat the experiment and obtain the average reading. That would be the best. Do not conduct this experiment in a dark room. Not applicable for this particular experiment. Sorry, Vishal. Take reading at eye level that is perpendicular to the scale of the stopwatch to avoid parallax error. Good job for this, Isabel. All right, so that is one of the most accurate answer for this particular page. Eye level must be perpendicular to the reading of stopwatch. Repeat the experiments a few times and find the average reading. Good. Do the experiment in a vacuum. Okay, this is not applicable for this particular experiment also. Sorry, Yuanming. The experiment must be repeated a few times to get average reading. Okay, turn off the fan in the room. Okay, but OFF, Nitya. Take several times to get accurate value, to get average readings again, Kailash. Okay. All right, so this is the general precaution that you can copy down or you can screenshot. Position of the eye must be perpendicular to the scale reading of the measuring instrument. So this measuring instrument, you have to mention based on the experiment. So in this case, the measuring instrument is actually the stopwatch. All right, so place the eye perpendicular to the scale of the reading to the stopwatch. If it's a pendulum or inertia experiment, repeat the experiment twice to find the average reading. So pendulum or the inertia experiment, you can write this particular precaution. If it's the spring Hooke's law experiment, you can use take the reading after the spring stop moving or stationary. All right. So because spring will oscillate, take the reading after it stops moving. That would be the most accurate one for the spring, the Hooke's law experiment. All right. If you need to screenshot, you better screenshot this now. All right, so next, if it's the light experiment, do the experiment in a dimmer or dark room. So this is going to be a bit of a problem because in practical exam, it's going to be like 18 to 20 people in a lab. So if some people do physics and you need to carry it out on a dark room, then it's going to be very difficult for the other students who's doing chemistry and biology. So I don't really think that they'll come up with light question though. All right, electric. This one electric is irrespective of whatever condition. So make sure the connection of the wires are tight. All right, secure the the connection tightly. All right, so that the electricity can flow. Okay, so screenshot this. I'm gonna go next. All right, remark to increase the accuracy. We repeat the readings and take the average, or the eye must be perpendicular to the scale. This one you have to change to avoid parallax error. Reject parallax error only. Reject the word parallel and you spell the parallax error wrongly. Okay, so please take note on this. Okay, we'll go to the non-guided question right now. Okay, I'm giving you guys a sample of a non-guided question. Non-guided question, they will give you all this hacksaw blade, they give you the plasticine, all this thing you need to check. Okay, and then they give you the question. So, what I'm gonna do right now is I'm gonna send this unguided question sample into the WhatsApp group so that you guys can have a copy of it right now. Give me very quickly. That's for Form 4. And just send to the Form 5. All right, I've sent it into the WhatsApp group already so that you guys can have a copy of it as well. So over here, diagram 3.1 shows a trishaw while carrying a passenger. Diagram 3.2 shows the same trishaw while carrying two passengers. He noticed that it's more difficult to stop or to move. All right, this is a keyword from inertia. All right, to stop or to move the threshold when carrying two persons. So the difference is 1 and 2 person. All right, and it is more difficult. So this is obviously a inertial experiment. To double confirm that it's inertial experiment, it's actually from the list of the apparatus. All right, it's already shown a Hawksaw blade. The only experiment in physics that uses Hawksaw blade and plasticine is the inertial mass experiment. All right, so in this particular case, all right, I want you guys to roughly identify what is the manipulated variable and what is the responding variable. Very quickly identify it. I already give you guys the keyword. It's inertia. So what is the manipulated variable and what is the responding variable? For those of you who have been still with me until right now, thank you so much. At least it's worth it, even though the other half is not in. So I hope all of you actually did learn something from me. And hopefully the Form 5 as well. My question was identify manipulated variable and responding variable. No, that's the reason why I cover the face. Okay. So while the rest is actually answering, if you recall back the beginning of the lesson, I did mention regarding the variables. The variables have to be a physical quantity that can be measured. All right. It can be measured, especially in the lab. So, how do you measure the number of passengers? How do you measure the amount of force needed to move and stop the threshold? How do you measure the difficulty for the threshold to stop? How are you going to measure the distance of the travel by the bicycle in the lab? Remember, manipulated variable and responding variable needs to be a physical quantity, and to be exact, since this is a practical exam, it needs to be using things that is actually inside, and especially in the list of the equation, the list of the apparatus that is given to you. Okay, so I'm gonna stop this. Okay, all right. So in this particular case, all right, it's already giving a hint of inertia. Question 3 type unguided question, especially if it's a physics question, it tests a lot of students' knowledge. So I have no idea about biology and chemistry. If the question actually comes out from physics, right, you have to be very careful, because in physics, when we talk about this, right, you have to it goes back to students recalling memory of the theory for the experiment. So if it's inertia, inertia only depends on mass. Whenever we talk about inertia, it always relates back to mass and mass alone itself. They don't talk about anything else. So the manipulated variable is actually the mass. The responding variable is inertia. But one particular problem is we cannot measure the inertia. So if you recall the list of the equation that is given to you, there is a stopwatch. Okay? When there's a stopwatch, which means there's going to be time taken. So having a hacksaw blade, within the 5 minutes of checking the apparatus, you can actually draft out your diagram already. And to identify within the 5 minutes of checking your apparatus, that 5 minutes, apart from checking the apparatus, you can actually write the MV and RV based on this particular list of equation. So the manipulated variable will obviously be the mass of the plasticine, because it's already number 4 given to you, it's plasticine already. All right. And then responding variable, because there's a stopwatch there, that's the only, not only lah, that's the other apparatus that you're going to use for the variable. So it's obviously going to be the time taken. Time taken for what? For 10 complete oscillation. You want 5, you want 20, can, no problem, because you are the one carrying out the experiment. Okay, but make sure it's constant throughout lah. So how are you going to plan this? How are you going to do this particular experiment? Okay, you can draft out your diagram. So in this particular experiment, all right, the first part says that based on the situation above, plan your experiment by using apparatus and materials provided. So always check back the materials and apparatus provided. The procedure should include method to handle the variables and a step of precaution. Okay, so in this particular case, all right, the procedure must include, screenshot this if possible, method of measuring the first value of the manipulated variable. You have to include the method of measuring the responding variable. And then you need to repeat experiment for another 4 sets of manipulated variable. It doesn't matter if it's past tense of passive, active sentence or a passive sentence. As long as your procedure, your steps is understandable, and whoever that reads it can, based on your procedure, they can carry out the experiment again, you are good to go. They don't, physics teachers are not English teachers. We don't emphasize past tense or present tense, all right, or future tense. We just emphasize that I read your sentence, I can understand, I can carry out. That's the most important part. And make sure one thing, we are very particular about spelling and also the unit. Okay, and precaution, make sure you write out the according to what apparatus and the precaution that we discussed just now. Okay, so the sample of this particular 4 marks is actually here. This is the diagram. You can sketch out. It doesn't have to be to scale. All right. Please make sure whatever that you know, label it out. Label out your diagram. Okay. It doesn't have to be to scale. And then you write the first thing. When you draw the diagram, make sure your first point for steps and procedure is set up the apparatus as shown in diagram. If you don't show this diagram, you have to write it out every single step. Excuse me. Sorry, 1 month didn't talk already, then suddenly talk 3 hours non-stop. So set up the apparatus as shown in diagram. If you don't draw the diagram, you will have to write every single step. Place the plasticine at the free end of the jigsaw blade and then clamp the jigsaw blade with a G-clamp onto the leg of the table, so on and so forth. You have to mention all that out if you don't draw the diagram. All right, so please try to draw the diagram. So this is the reason why Form 4 students when you're supposed to write experiment, don't ask whether you need to draw the diagram or not. Okay, so you need to draw the diagram so that you practice how to draw. All right, so number 1, this is how you manipulate the first manipulated variable. how you measure. You measure 10 gram of plasticine using the electronic balance and place it on the free end of the blade. So this is 1 mark here. Displace the blade horizontally and measure the time taken for 10 complete oscillation using a stopwatch. So this is how you measure the responding variable. So this is the 2nd mark. The 3rd mark is to repeat the experiment. You need 4 times repeated. You need to mention it out. So does it have to be 10, 20, 30, 40, 50? Not necessarily. You can go 10, 15, 20, 25, 30, 35. You can go 20, 40, 60, 80, 100. It's up to you. But the difference have to be the same, and minimum manipulated variable, minimum 5 reading. So if you have extra time, you want to do 10 reading, can or not? Can. You want to repeat 2 times, can or not? Can. Okay? I hope that answers some of your questions. All right. And then state. So this is 1 mark. The question also state 1 precaution. So avoid parallax error when taking the reading with eye perpendicular to the scale of stopwatch. Okay? So this is 1 mark. So this is actually 4 marks over here. All right. So I hope that would be clear with all of you. All right. So screenshot this. I'm going to go next already. All right. Carry out experiment. Tabulate the data. So what data do we have? We have the mass and we have the time. So sketch the table. All right. So can you all roughly sketch a table right now? Just roughly sketch onto the side of the paper. All right. Sketch the table to have your data of the manipulated variable, responding variable, and then the data's whatever that is over there, and try to upload this. We have, I think, less than 5 slides already right now. Just sketch, all right? No need to be exact. Sketch also so long. Ah. All right. Okay, since not many people are either still doing, I have no idea. Okay, I'm just going to close it very soon. In 5, 4, 3, 2, 1, 0. I know you guys are exhausted, so am I. So don't worry about that. Anyway, Bunhan, once again, thank you for responding. I'm gonna use yours again. Okay, so Bunhan sketch actually mass of the plasticine, G is the unit, time taken for the 10 complete oscillation with the unit of second. So 20, 30, 40, 50, 60, decimal places, okay. And then he agak-agak put the values over there. So actually, if this one is the table 5 marks, it will definitely get 5 out of 5 already. Okay. So sample of my table would be like this. As I mentioned previously, for the table, you don't have to spell out the mass or anything. You can just write a symbol M, comma G, T, comma second. And then because I'm going to find the period, so that's capital T equals to small t over 10 seconds. So this is how I sketch my particular table. So if you're still in front of your screen, you can actually screenshot that. Okay, so I'm going to go next right now. Now, on a graph paper, plot the graph based on this. So I'm just going to sketch this particular one. The question, if you notice, unguided question, they didn't tell you what graph that you tabulated. It's actually based back onto your table. So we examiners cannot mark based on our answer scheme, but based on your data. So from my data, it's actually period of oscillation. So that's capital T, unit second, and then mass gram. So if it's like for Bunhan didn't divide it by 10 to find the period of the oscillation. His is actually 10 complete oscillation. So that's cap small t per second. Bunhan, remember your unit, and then mass gram. Okay, so that is actually the graph that is going to be plotted. And make sure you write the title of the graph on the graph paper to get the full 5 marks. Okay, then okay, this one don't bother. To find the relationship between the manipulated and responding variable, there is only 2 answers that are going to be accepted. All right. Throughout most of physics question, it's always a straight line graph. Always a straight line graph. So if your straight line passes through the origin, let's just say t second mass gram. So this is t directly proportionate to m mass. If it doesn't passes through the origin, either above or below, but it is still a straight line graph. So this is t linearly increasing to m. All right, so there's only 2 answers. All right, we don't accept as m increases, t increases, because the question says based on your graph. If based on the graph, it's definitely directly proportionate or linearly increasing. That's all. No third answer. I repeat, no third answer. Okay, so please take note of this. All right, so as I said, I only have 5 slides more. So I hope that whatever that I've mentioned to you guys are okay with it. You actually have write out whatever tips or that I've mentioned. I will share 2 links that I have watched yesterday in order to prepare all the slides. You guys can go through that again. I've also recorded the lesson so you guys can go through it again. So before we end, okay, as usual, I need a feedback form of what you guys know and everything. So please do fill up the feedback form. It's inside the Google Meet chat box right now. All right, fill it up. If you have any questions, you can ask me, message me or whatsoever. Next week we'll go back to physical class already. So Form 4 and Form 5, please make sure that you come back to school. There's no rotation Group A or Group B already. Okay, so for Gamma, for Alpha, please make sure physics, please go to the physics lab. All right, 5 Omega, as usual, physics lab. For Puan Syahada's class, that depends on Puan Syahada lah, okay? So any questions so far that you want to ask me, especially on the Form 5s?